Hello, this is Joshua Gorospe, and I will be giving a talk on Web3 cross-chain tools and testing using Robot Framework. So here's a little information about my background. I'm currently working as a staff test engineer at a startup called WebAI, and I've been a tester for approximately 18 years in agency and product companies. I've worked on cybersecurity, machine learning, ad tech, mobile app, e-commerce, and blockchain projects. I really enjoy researching blockchain technologies, experimenting with test tools, and learning more about rapid software testing methodology. I'm also a part-time writer. I use many types of tools in my work, but I like considering myself as simply a tester. Here's an overview of the sections we'll cover. There's two parts. I'd like to briefly introduce you to Ethereum and EVM compatible blockchains. This will be helpful if this is your first time with these subjects. And also I will then get into the strategies that we'll be covering today for the Robot Framework side of the Web3 tools and how they integrate together. And I will be showing very detailed graphs and workflows to describe how the tooling in Web3 can work with Robot Framework. So the key takeaway is the Robot Framework Solidity Testing Toolkit that I created, which was also featured on automation testing with Joe Colantonio. For your convenience, you can use this QR code to get the repo on your phone and follow along as I present this talk. Part 1 will feel like a bit of a rabbit hole if this is your first time with Web3. I need to go through a couple of basic things, but don't worry, it gets better. So Ethereum, EVM, and the cross-chain future. Ethereum set the standard, but cross-chain is the future of the technology, and Ethereum and Solidity specifically have vast and growing capabilities. Ethereum itself is often misunderstood as just a cryptocurrency. The co-founders of Ethereum originally sought to create a world computer, and Ethereum and its EVM are actually Turing complete. There's a growing importance of cross-chain communication, bridges, and any dApps that connect to multiple blockchains in the Web3 industry. Decentralized applications are what's often called dApps. The back-end code is the smart contracts. They run on a decentralized network, and they don't have a centralized server. They use the Ethereum blockchain for data storage, and smart contracts are their app logic. Common cross-chain dApps are decentralized exchanges and also bridge aggregators. So, cross-chain use case usually involves sending various types of cryptocurrencies to other blockchains. And I will show you a quick example called ChainArc. So this is ChainArc, and the way it works is you can send various types of cryptocurrencies, and you can send it at the cheapest price, or you can send it the quickest possible, but that costs a little extra. And basically it supports these 8 different types of blockchains. So what is the Ethereum virtual machine? The EVM is a decentralized environment that executes code. It uses gas to measure the computational effort and ensures efficient resource allocation and secures the network. Basically, smart contract execution is one of the most important parts that we need to know about, and security and decentralization. It ensures cryptographically secure processes and enables transactions and functions to happen without any type of trusted intermediaries. This is a visual representation of the EVM. This comes straight out of the ethereum.org developer docs. Take note of the volatile state and also what's immutable and what's persistent. EVM compatibility is the ability of other blockchains to run the EVM and execute Ethereum smart contracts. This is what enables cross-chain development and deployment of dApps. There's several benefits of this: portability, reusability, expanded user reach. Examples of EVM-compatible blockchains that expand beyond Ethereum's capabilities are the top compatible ones, such as Tron, Binance Smart Chain, Arbitrum, Base, Polygon, Avalanche. So these TVLs you see, they're as of September 7th, 2024. Gives you a good idea of the activity of what's going on in each of those top blockchains. Each blockchain offers unique features, interoperability, and capabilities, which is too much to discuss here. The number of EVM-compatible blockchains is growing and expanding, and hundreds of EVMs exist. You could check that out on DeFi Llama if you want to go dive into it deeper. RPC node providers and JSON RPC API for Ethereum clients. So basically, RPC node providers are the infrastructure that allows applications to connect to the EVM blockchain. This allows Web3 wallet applications, an example is MetaMask, to connect to those blockchains. And many types of node providers exist. There's Alchemy, there's Infura, Moralis. For the examples later on in this talk, I'm going to be using mostly Alchemy and Infura and a few public RPC endpoints. JSON RPC API for Ethereum clients is an interface and API specification for Web3 developers. Ethereum clients use the methods from this specification to interact with EVM-compatible blockchains. It defines 61 API methods for standardized Ethereum client communication. Ethereum client tools, SDKs, and libraries that are common are basically you could use curl or WebSocket Cat. There are examples on how to use those common tools in the JSON API specification. And there's also several Web3 libraries and SDKs that exist. Some examples are ethers.js, the Go Ethereum client. In Rust, you'll find Foundry and ethers.rs. These aren't the only ones you could use. There's a lot of them, and you can find them in any Solidity curated GitHub lists. This diagram shows that blockchains can be treated like any other backend system that you're used to testing. By now you've probably heard RPC mentioned a couple times, and you thought to yourself, wow, I think I've heard that before. Robot Framework uses a similar technology too. If you thought that, then you're correct. The remote interface uses XML RPC. In fact, several examples in part 2 use the Robot Framework remote interface. But don't worry, we're getting to that soon. In this slide, we'll go over examples of public RPC endpoints versus private RPC endpoints. In MetaMask, when you use the default RPC endpoint, you're actually using a public endpoint that's used by basically everybody out there. When you sign up for a free tier in Alchemy or in Infura, you're signing up for a private endpoint with your own API key, so you get to control who uses it. In this slide, I'd like to talk about being safe and protecting yourself while working in Web3 and blockchain. There's an article called Ethereum is a Dark Forest. It's based on a book with a similar name. It's basically talking about how to avoid detection and staying away from these very dangerous bad actors. The article talks about a real-life Ethereum mainnet horror story, and the lessons learned are try to protect your personal information, try to protect yourself from detection, avoid exposing any kind of personal information about yourself, especially your wallet address. Try to have dedicated test wallets, consider a high-quality VPN, and always assume that you're exposed. In addition to the basic protection topics from the previous slide, cleanroom environment testing using Hardhat or Foundry is a safe option to use, and it's also repeatable. That allows you to use a local node with its own local RPC endpoint. It allows you to also run automated checks with no actual gas costs. Another option is read-only transactions through node providers and also using specialized Web3 SDKs. Some examples that trigger transaction fees are performing a transaction using the methods of a smart contract or sending cryptocurrency from your wallet address to another person. So now that you have this Web3 knowledge, it's hard to absorb. I know this from personal experience, and I hope you're still with me. And of course, knowing is half the battle. So here's a brief disclaimer. Just want to be transparent with all of you. These strategies were created to help me research and experiment with different types of Web3 tools. They were only meant for educational purposes and to encourage positive blockchain and Web3 awareness. And also, I did not intend to teach anyone how to use this for any kind of unethical purposes or to put yourself at risk. These strategies were based on public examples and public specifications. So please be good to your fellow man and protect yourself as well. And I recommend you review Part 1 later. In this slide, I'd like to go over a multi-chain Infura WebSocket bot strategy. The strategy demonstrates 3 API methods from the 61 existing Ethereum JSON RPC methods. One of them is ETH fee history, which monitors gas fee information. The other is ETH get block receipts, which monitors recently completed transactions. The other is ETH subscribe, which monitors pending transactions on a recently created block. This demonstration will connect to Ethereum and Avalanche to monitor transactions on those blockchains. And it will gather transactions and list blockchain explorer URLs for each transaction. The tools used with Robot Framework will be Docker, Infura RPC endpoints, and WebSockets through WebSocketCat. Now I will demonstrate the multi-chain Infura WebSocket bot. You can use the link below to follow along, or you can scan the QR code from your phone to view it in landscape mode. So I'll give you a second to do that. Okay. Right now the Docker container is building. The Infura WebSocket bot is now running. And as you can see, connected to Ethereum and to Avalanche. Okay, it should be done. The Robot Framework automation subscribed to Ethereum mainnet to read the most recent transactions and also to gather gas fee history here at the top. These are the recently completed transactions from before. These are the transaction hashes that were collected, and those hashes were converted into URLs, which we can use to go to Etherscan. So this was gathered by the Robot Framework automation. Same was done to Avalanche as well. Let's take a look at the results now. So you can see from here, monitor gas fee information, we monitor recent blocks and completed transactions. Also monitored for new pending transactions. Also gathered the transactions and logged them as Blockchain Explorer links. In this slide, I'd like to discuss an Alchemy SDK bot strategy. This strategy demonstrates two examples from the 22 NFT API methods found in the Alchemy SDK. Get NFTs for owner, which gets the total amount of NFTs for an owner's address. Get NFT metadata, which gets the current metadata about a specific NFT. This demonstration will connect to Ethereum, but you could easily switch it to other blockchains supported by the Alchemy SDK. It uses the Robot Framework remote interface. The tools that are used are Docker, Alchemy SDK, and the Node remote server. So at this point, I'd like to demonstrate this code, and same as before, you could use the link, or you could scan the QR code. Okay. Now I'm going to run the automation for the Alchemy bot. Similar to the Infura bot, this uses a Docker container. This will run the Node robot remote server. And it's done. It's very fast. So the first task actually checks the NFTs owned by Vitalik Buterin. The second task gathers current metadata about a specific NFT collection. Gets down to details about the deployer address, the name of the actual NFT that we're looking at here, the specific NFT. This is the collection name, by the way. The token type, and also information like the Discord URL. Okay, let's check out the results. Here are the results of the Alchemy SDK bot automation. In this slide, I'd like to discuss a hard hat local Ethereum blockchain strategy. This strategy demonstrates 12 custom-made test keywords that run some of the methods of a Solidity smart contract. It connects to a local blockchain node that behaves like Ethereum, but without the risks of mainnet or testnet. It uses the Robot Framework remote interface, and it uses Hardhat and Ethers.js, and the Node Robot remote server created by Comic. Again, take this time to use the link below or scan the QR code as I demonstrate the Hardhat local Ethereum blockchain strategy. Running this particular example requires two terminals. I'm going to run the local node in the terminal on the left. Okay, the setup on the left has finished running. Now I'm going to run the actual tests. While the tests are running, keep an eye on the console log on the left. Now, it just finished this very quickly. Starting from the top. So basically what happened here on the left, while this local node is running, the test is checking on the smart contract that was deployed, which is a test token. Just checking on the symbol of the token, the decimals it supports, the total supply of the token, the address, of course its balance. Also here, we're performing actual transactions in test 7, 8, 9, all the way down to 12. You can see a gas report here generated by actual transactions shown here. When you generate a transaction, that's when gas is spent. That's a quick overview of this example. Remember, if you'd like to see the code, check out that QR code that I shared earlier. In this slide, I'd like to discuss a parallel running Foundry and Playwright test strategy. This strategy demonstrates two custom-made parallel running keywords that test a Web3 mock wallet connected to a local Foundry node. This demonstration will connect to a locally forked blockchain node that copies the Ethereum mainnet. Now, Foundry can very easily and quickly fork other EVM-compatible blockchains. You just provided a valid RPC. The tools used are Foundry, Paybot, Playwright, and WogMe. So now I'll demonstrate. Just like before, use the link below to follow along, or you can scan the QR code and view from landscape mode. Okay, similar to before, I'm going to be starting the locally running node on the left, and then I'll run the tests on the right. So let's start this. At this point, you can see that the smart contracts are being compiled by Foundry. It's deployed to an address here. That address right there. That's the actual address of the contract we're going to interact with. This is another address here. There are actually two contracts that were deployed. This contract is dependent on that one being deployed. Now I'll run the tests, and you can see the interactions while a Playwright test is interacting with the wallet. At this stage, the Robot Framework browser library is being initialized. And now the tests are being run with Paybot. You can see here that some ETH was spent. You'll see in a minute from the console that the tests that ran the actual transactions have already completed. Now the Playwright test is basically checking that this particular wallet, mock wallet app, is showing that the ETH has been spent for those transactions. Just very briefly walk you through this very long output from the Foundry automation here. This is the address it interacted with. It's the ERC20 token Solidity contract. We created a QA token. And then we sent some tokens to an address to generate some activity in the logs, and also to check that from the actual mock wallet we are making sure that the Ethereum is being spent and showing up properly from the wallet. Let's take a look at the result file. You can see here that Paybot ran both tests at once, and it shows very good results. In this slide, I will discuss a parallel solidity, security test, and vulnerability scanning strategy. This strategy demonstrates how to create your own solidity auditing automation system. It will run parallel consensus solidity tests and vulnerability scanning in Docker containers orchestrated by Paybot. This demonstration retrieves target solidity contracts to audit from Blockchain Explorer websites Etherscan and Polygon Scan. The lists of targeted contracts and Blockchain Explorer websites are handled by Robot Framework Data Driver. The tools used by Robot Framework in this strategy are Docker, Consensus Diligence Tools, which is a collection of various types of security tools targeted at Solidity smart contracts, Etherscan API, Polygon Scan API, Paybot, and of course, Robot Framework Data Driver. Just like in the other demonstration slides, you can use the link below, or you can scan the QR code from a phone and view it in landscape mode. Now I'm going to run the automation. Right now the automation is downloading 4 smart contracts, 2 from Ethereum and 2 from Polygon. These smart contracts will be scanned and tested by the consensus diligence tools. The 2 diligence tools that we'll be using today are Mithril and Napalm. Mithril is a vulnerability scanning tool that checks EVM bytecode. Napalm is a static analysis tool. The vulnerability scanner passed. It didn't find anything in the EVM bytecode of the 4 contracts. 2 of the contracts passed the Napalm test. The other 2 failed on this issue related to wallet security, privileged functions. Let's take a look at the results. As you can see from the results, you can see here that the Napalm test is failing on this issue. And now we've come to the end, and hopefully this presentation has made you curious about Web3 tools and how they can work with Robot Framework. If a Solidity developer ever asks you, why Robot Framework? Isn't it just a Selenium project? Why not Mocha.js? You'll probably have interesting information to share with them. And thank you for attending this presentation, and big thank you to Adam Hepner for letting me attend and do this presentation. If you have any questions, I'll stay on to answer them. And if you enjoyed this content, I also teach workshops. And here's my contact information. And I hope to talk to some of you after this presentation's over. Have a good day, wherever you are.